Hey everyone, welcome back to the electricity series. This is part 5, and today we're talking about something super practical, how to calculate efficiency and cost. Ever wonder how much energy your devices actually use, or how much it's costing you? In this video, we'll break down how to measure efficiency, figure out how much energy is lost, and even learn how to calculate the cost of electricity using real-life examples. Let's jump in and make those numbers make sense. Let's start with efficiency. Energy cannot be created or destroyed. It just changes from one form to another. That's called the law of conservation of energy. I mentioned this previously in one of my other videos. But nothing is 100% efficient. When energy changes from form to form, it's usually lost. Not gone, just converted into something less useful, like heat. Think of a light bulb. It gives off light, but it also gets hot. That heat is energy too, just not the kind you wanted. So remember, energy always goes somewhere, just not where you want it to. So as you can see here, there's some energy input and energy output. The energy output is less than the energy input because some of the energy is lost through forms of heat, sound, and light. How to calculate energy efficiency? Efficiency equals energy output divided by energy input. The smaller number divided by the bigger number. To make that into a percentage, you just times it by 100. Let's do some practice questions. A fluorescent bulb produces 400 joules of light energy from 2000 joules of electrical energy. Alright, by already looking at these numbers, you can tell that this light bulb is not very efficient. So you have efficiency equals question mark, that's what we're trying to find out. We have energy input, which is 2000 joules. In my previous video, I taught you what joules was. Be sure to check that out. We have energy output, which equals to 400 joules. And we have the formula. Efficiency equals energy out divided by energy in, and we want it in a percentage, so we times it by 100. Now let's plug in the values. So we have efficiency equals 400 joules. Make sure you always include the units. 400 joules divided by 2000 joules times 100. So you get efficiency equals 0.2 times 100, and then you get, see, if you look at this, my equal signs are all lined up, but now just for this 100, they're not. It's okay, we'll shift it over. You have efficiency equals 20%. So as you can see, 20% is light energy, and the other 80% is either sound or heat. Now, you can write a therefore statement, but I'm not going to. That's going to take up too much time. Alright, next slide. Calculating cost. Cost equals rate times energy. And rate is basically the cost of electricity. So let's say it's 0.09 cents or $0.09 per kilowatt hour. And that's basically what this is saying. So cost would equal money per kilowatt hour times how much ever you use. Let's do a practice question. You are charged $0.09 per kilowatt hour. During the day, your household uses an average of 300 kilowatts. What is the cost of your electricity bill to use electricity 20 hours of the day? So, as you can see, we just need to break this down a little. So, we have power, so P equals 300 kilowatts, and we know that power is potential difference times current, or V times I. We have delta time, or change in time, which I explained in my previous video, which is 20 hours, and we have the rate, which is equal to 0.09 per kilowatt hour. For the dollar sign, that's a fancy Saturday here. Now, as you can see, the problem is cost equals rate times energy, but we don't have energy. If you remember from my previous video, you calculate energy using V, potential difference, times I, current, and change in time. So we know that power is V times I, and we already have delta time, so we just need to times power and delta time. Right. So let's get energy. Energy equals P times delta time. And we have energy equals 300 kilowatts times 20 hours, which is equal to 6,000 kilowatt hours. And to break this down for you, we basically multiply the numbers, and if you take kilowatts and hours and you times them together, you get kilowatt hours. It's that easy. So now we can calculate cost. So cost equals rate times energy. We have, plug in the values, we have 0.09 dollars times 6,000 kilowatt hours. We get $540. There we go. It was that easy. So if your rate is $0.09 per kilowatt hour and you spend 300 kilowatts of power and you use it for 20 hours of the day, you'll spend approximately $540. How cool is that? So now you can ask your parents, how much do you pay for electricity? And maybe you can go backwards and see how much the rate is, what your how much you use, like how many kilowatts you use, how long you use it for, and how much power you use. How cool is that? So I've added some extra practice questions for you guys today to test what you learned. These are some pretty basic ones. I'll put some more complex and better ones in the description below. And that wraps up our final video in the electricity series. If you've been following along from the beginning, thank you so much for sticking with me through topics like electricity circuits, current, resistance, and more. I hope you've learned something new and exciting in each episode. This marks the end of the series, but it's definitely not the end of the channel. I'd love to hear from you. What topic should I cover next? Drop your suggestions in the comment below. With that said, I'm probably going to make the next video on the solar nebula theory. So if you are into space, planets, and the origins of our solar system, stay tuned. If you enjoyed the series, don't forget to like and subscribe so you don't miss what's coming next. Thank you for watching, and always stay curious.